is about 5 o'clock for once. Sort of on time. Let's make sure you can see what we're doing. We're doing that. Okay guys, welcome back to London. Welcome back to Robert's Co, another live jewelry making session. We're continuing some work on some silver. I've been working on some silver ingots. I'm experimenting with a new technique I've invented called dry quenching, which isn't really a new technique. It's a new way of using. Jewelers have been using steel blocks as a heat sink for a long time, just not necessarily for quenching wire and ingots. Mainly, I and other jewelers that I know have used it. For, if you get a solder job slightly wonky, if you heat it, if the joint moves when you're heating it up and you need to reposition it, that sort of thing, you can put the job on a steel block. It will sap the heat out of it real quick. You can reposition it, makes it cool enough to handle, reposition it, go again. If you search for quench it, when you're making wire when you're pouring gold ingots, first of all, when you're pouring gold ingots, if you have a look at the discussions online, whether you should quench them once they're poured or not, this should be like the science of this should be sort of settled by now. People have been doing this for thousands of years, but it's not. People are just online arguing about whether you quench it or whether you don't, whether you air cool it or quench it. That's just from pouring. Everyone I see on social media, when you see them, if you go on TikTok and Instagram and all that and watch people melt silver, most of them I see instantly, they quench it when it's pretty much, I think, red hot, which is too hot. Even if you are going to quench it, you should let it cool down a bit. But then the next shot is some fabulous piece of finished jewellery. So I don't know, but yeah, it's not a done. It's a discussion online. I've always quenched solder jobs without issue, and I think most people have. I think at that stage, once the thing's formed, the issues don't present themselves. But in my experience with silver, not so much with gold. If you quench it, you get no end of problems. From trying to form ingots or quenching ingots and then turning them into wire, it causes brittleness. I'm not sure whether again, on the internet, quenching it might soften it, it might harden it, I don't know. But it certainly, it might soften it, but make it brittle and prone to cracking, paradoxically. It definitely does, in my experience. Quenching gold is not an issue, or doesn't present the same issues as silver. Quenching silver, I was ending up with subsurface water. When I was rolling it out, it was almost like it was wringing out a sponge, which is a bit of an exaggeration, but you would get water on the rolling mills. Like the water would be subsurface, it would come out, it would blister as well, and it definitely caused cracking. It was quite soft. It was workable, but yeah, quenching it caused problems. But I think cooling it too slowly, so if you heat gold and silver up, there is a way of, if you wanted to, really harden gold and silver, harder than work hardening. There is a way of doing it, heat treating it by getting it to annealing temperature, then cooling it really slowly. But I think, I think it's actually really different. If you wanted to do that, I think it's actually really, really hard to do, because I think that's what most people are actually doing, but they're getting it wrong. Two wrongs make a right. So they're air cooling gold, which if you got it right, it would be rock hard. But luckily we're air cooling it, getting it wrong in that sense. We're like, the cooling speed is critical to that process, and I think you need a furnace to do it properly. Doing it just in the air, it would be a pure fluke if you actually nailed it. Air cooling silver does work, but what I've been experimenting with is using my steel block to put the silver on, and with silver and gold, you see the heat just drain out of it. So it's not as rapid or as shocking for the metal as quenching it in liquid. I think with gold, I've seen people say that with red, quenching it's essential, but because of the problems you can get more problems from quenching than you can from air cooling. So I think a lot of people, the consensus seems to be that alcohol is slightly kinder to the metal than using water. So a lot of people were suggesting alcohol on red gold or rose gold because the quenching is more essential than on yellow gold. But I'm kind of experimenting with using the heat sink process. So we're cooling the gold. Again, it's kind of like the next step down from out. So you've got water, which cools it really rapidly, shockingly fast for the metal. You've then got alcohol, which is not as rapid. And then this steel block version, we're basically using a steel block as a heat sink, is even less rapid. In fact, the cooling kind of decelerates. So obviously, first of all, it drains the heat out quite quickly, but then the heat is taken up by the steel block beneath it. So as the metal's cooling, the steel block is, to some extent, warming up and reflecting a little bit of heat back. So yeah, try and figure out what that does. It doesn't seem to be hurting the metal anyway. This is, at the moment I'm turning this, which we melted. I'm working on another one actually, another little experimental one. That is sterling silver. It's probably about 6 or 7 mil at the moment. It's about 50 grams of silver there. That is going to be 3 mil wire. That needs to go through the rolling mills. But these three, I'm in the process of turning into core. These have just been through hole 24 on that, and they need to get down to probably about hole 27. So we've got a few to go. I do 2 anneal, 2 anneal. In the early stages, when it's sort of squared off, I'll do 3. As it gets closer to the actual oval shape, I'll drop to 2. You can probably get away with 3, but I've been doing it so long, I don't want to crack it at this stage. So 2 anneal, another couple anneal. So yeah, this needs annealing, and then we'll go hole 25, hole 26, anneal again. What will happen, you'll know, like you can see, this is real springy. A lot of work, like work hard and tension in there, stressed. If you carry on going and going, eventually it does crack and break. So you have to do this anneal to take out the stress and the tension and soften it basically. And what you'll see, I don't know whether you'll see it from up there, but you'll certainly see it from here, is as it relaxes, it will collapse down towards the board. With each subsequent one, let's do the smallest one first. With each subsequent one, because the board heats up beneath, the process gets a little quicker. We'll get it up to a dull red. According to the internet, which is often wrong, but according to the internet, especially on this subject, 50-50. Doing gold, annealing gold, they call it like a heat sink, a heat soak. You kind of leave it at the temperature for a little while and then let it cool. With silver, apparently the consensus seems to be to just get it up to temperature quite quickly, and then you don't need to soak it in the heat. Just get it up to annealing temperature and call it a day. I did actually ask our AI to research it, and the AI was saying for both gold and silver, air cool. Just quench it when you've got your. The AIs seem to think that you air cool. until you've got your final shape, and you only quench when the shape's finalised. But then that is obviously just, the AI is learning from everything online, so half the internet's, they can't all be right. And they've all got different opinions. The AI has obviously picked a side. And they picked the AI picked air cooling. Right, it's a nice red colour. Just let that go a little bit off red hot. Boom. This one's a bit springier, so we should see this one collapse a little bit more. The sterling silver collapses because it collapses a lot quicker than the 9 carat. It's just the 9 carat. I think the silver. I think in theory gold's supposed to be a better conductor than silver, and that might be true with the pure metals, but because what we're working with are the jewelry alloys, 9 carat is not as good a conductor of heat as the sterling silver. Maybe it's just because the silver's 92.5% pure metal, and the 9 carat is only 37.5 minimum. So possibly if we were working with pure gold and pure silver, the gold might conduct it slightly quicker, but when you're working with these alloys, the sterling silver, heats up a little bit quicker than the 9 carat when it's spread out like this, because it conducts the heat a little bit better within itself. Put the weight a bit on the bottom bit. The other advantage of cooling them quite quickly on that steel plate is, rather than waiting for them to complete the air cool, is it cools them down a lot quicker, so you can get back to the drawer bench and start working on the metal again pretty quickly. Yeah, that first one is actually cool to the touch now, so it's cooling them down quite quickly. I don't know about, oh yeah, no, that one, it's warm, but it's warm, but it's not hot. A lot of that's probably the, oh no, the block, just say that's the residual heat. It's not, it's just the metal in the silver. Block's freezing. Yeah, so far, no issues cooling the silver quite quickly using the steel plate. Or the gold, we did the gold yesterday. The gold I took right the way down from poured 7 or 8 mil ingot. Used the same process when annealing it, using the steel plate to quench it, and I got it down to 1 mil wire, over a metre of 1 mil wire, so it was about 10-11 grams of 9 carat. Poured it out into a 7, quite small, chunky 7 or 8 mil square, well, rectangular, 7 by 8 probably, comes out of our graphite ingot moulds. Took it all the way down to 1 mil using the bench block to quench it, and it came out okay, but it's the first one I've done in its entirety, so I can't say it definitely works, because it could have just been luck. Right, see you in the next one. Toodles!